My dear students, good morning all of you. Today we are going to discuss the types of forces. In the previous class we discussed about the Newton's second law, significance of the Newton's second law, that is derivation of F is equals to ma, and also the impulse we discussed. Here now we are going to discuss about the types of forces. There are two types. One is, first one is the contact force. The second one is non-contact force. Basically they are divided into two types, contact force and non-contact force. Then what is meant by contact force? Contact force means, first one is contact force. Regarding this contact force, the force between two or more bodies when they are in contact is called as the contact force. That is, the force between two or more bodies when they are in contact is called contact force. The force between two or more bodies when they are in contact is called as the contact force. So can we get examples for this contact force? Any force which is between the two or more bodies when they are in contact means, first one is frictional force. That is the best example we can have. Frictional force means, for example, whenever a body is moving on a rough horizontal surface, the friction always acts between the surfaces in contact. So here the block is in contact with the surface, and when it is in motion there exists a force called as frictional force. Suppose if this is pulled with a force F, that means the second one is applied force, pull or push, that also comes because it is again in contact with that. And the third one is normal force. Normal force means when this object exerts force on the ground, in turn the ground will also exert an equal and opposite force, which is nothing but normal force. Like that, frictional force, normal force. Next one is tension force, which exists in the strings. These are all different types of contact forces. That is spring force. All that comes under this contact force. Then what is meant by non-contact force? There itself we have the answer. Non-contact force, which is also called as the field force. Non-contact force is also called as the field force. What does it mean here? The second one is non-contact force, or sometimes it is also called as field force. The non-contact force or the field force means the force between two or more bodies without any physical contact is called as the non-contact force. The force between two or more bodies without any physical contact, is called non-contact force or field force. That means the best examples what you can give for this non-contact force. electrostatic force. Electrostatic force is a non-contact force. The second one is, because if you consider two charged bodies separated by a certain distance, even though they are not having any physical contact between them, there exists a force of attraction or the repulsion. If they are like charges, there exists a repulsive force. If they are unlike charges, there exists an attractive force, which you studied in our lower classes. And similarly, the second one is gravitational force. Gravitational force is nothing but force between two bodies separated by a certain distance. And also magnetic force, that is the force between two magnetic poles. That is comes under magnetic force. So, the force between two or more bodies without any physical contact is called as the non-contact force or the field force. And here electrostatic force, gravitational force, and then magnetic force, these are all comes under non-contact or field force. Now, here some concepts related with the contact force. Let us consider a concept based on this non or contact force. What you can say is here, two bodies, capital A and capital B, are masses, M1 and M2. Two bodies, capital A and capital B, are masses M1 and M2, are in contact with each other. When a force capital F is applied on block capital A as shown in figure, then find acceleration of system of blocks and also the contact force between them. Suppose you are asked a question like this. Two bodies, capital A and capital B, are masses M1 and M2 are in contact with each other. When a force capital F is applied on block A as shown in figure, suppose this is the figure that what I have given, this is the let us consider this is the block A, this is block B, and now a force F is applied on this. This is having a mass M1 and this is having a mass M2. When a force capital F is applied on the block capital A, then find the acceleration of the system of blocks and also the contact force. When you are asked like this, then what to do? First fundamental thing is, whenever these two blocks are in contact with each other, then there exists a contact force or not. Now, how to solve this? Let us say this is A, this is a B, and now having a mass M1, this is having a mass M2, and a force capital F is applied. Whenever the force capital F is applied on that, here these two are in contact at this place, then there exists a force between them called as the contact force, Fc. This is the contact force between them. As long as the system of blocks are in contact, they should travel with the same acceleration. This is the first point. Whenever a system of blocks are in contact with each other, and when a force is applied on the block, then all the blocks should move with the same acceleration. And once you got the idea of this, first you have to take the free body diagram. If you have the idea of this free body diagram, then the problem is very simple. Free body diagram means it is the graphical representation of an isolated system or an isolated block along with the direction of forces. It's called as the contact, it's called as the free body diagram. That means free body diagram means a graphical representation of individual blocks along with the direction of forces that are acting on it. That are acting on it is called free body diagram. So a graphical representation means, or a graphical illustration, what you can say, of individual blocks along with the direction of forces, along with the forces and its direction that are acting on it is called as the free body diagram. Now once you got the idea of this, now first of all, if you can observe the free body diagram for this, that is free body diagram, what you can take for block A, if you can consider what are the forces that are acting. This is acting in this direction is F, and here the contact force is in this direction Fc. The block moves with an acceleration A in the forward direction. Therefore here net force always given by F net is equals to F minus Fc. Because this is great, because this moving, this must be greater than this. Therefore, this must be equals to M1A. And for the second block, if you consider, this is having only Fc, this moves an acceleration A. Therefore, Fc is equals to M2A. This is equation 1 and this is equation 2. If you are able to take the free body diagram for any system of blocks, then we can easily calculate the acceleration and also the contact force. So add equation 1 and equation 2 plus Fc minus Fc cancelled. F is equals to M1 plus M2 into A. Therefore acceleration A is equals to F by M1 plus M2. That is the net force by total mass. If you know that the net force by total mass, that will give you the acceleration. Thereafter you are asked another one, contact force between A and B. Contact force is Fc, that is from equation 2, it is M2A, that is M2 into F by M1 plus M2. If you are asked to find out the contact force, when force is applied on M1, the contact force is second mass into applied force by total mass. If this is acting on the second block, then it becomes M1F by M1 plus M2. Very simple. For any given numerical values of this two, we can easily calculate the, for example, if you are given, an example is given like this. Suppose if M1 is equals to 2 kg, M2 is equals to 3 kg, and applied force F is equals to some 10 kg, 10 Newton. Then, what the acceleration if you are asked? Then acceleration directly you will get A is equal to net force by total mass. F is 10 by 2 plus 3, that is 10 by 5, which is equals to 2. So acceleration is 2 meters per second square. And the contact force, suppose you are given like this. This is 10 Newton is applied on this, and this is 2 kg block, and this is 3 kg block, this is M1, and this is M2 if I are assuming in the diagram. Then what you are going to get? A is equal to omega. Straight away you can get it. Then contact force is given by Fc is equals to M2 into A. What is M2? 3 into A 2. So contact force between them is 6 Newton. This is how we are going to calculate as and when we are given the numericals. For general solution, when a system of 2 blocks are given, is like this. Is it clear? Now come to the other one. The second concept is concept 2. That's what you are given is when 3 blocks, capital A, capital B and capital C, masses M1, M2 and M3 are in contact with each other. 3 blocks, capital A, capital B and capital C, mass M1, M2, M3 are in contact with each other. When a force, capital F, is applied on block A as shown in figure, when force capital F is applied on block capital A as shown in figure, then find acceleration of system of blocks, acceleration of system of blocks, and also contact force between A and B, and also between B and C. This is what you are given, and you are given these are the 3 blocks. This is A, this is B, this is C, and a force capital F is applied here. This M1, this is M2, and this is M3. These are the system of 3 blocks that are experiencing. Then what is going on? Here, whenever you are given, let us say this is what you are given. This is the force F. This M1, A, M2, B, and this is C. And once you are given like this, then what happened? If you can observe at this point here, there exists a contact between these two A and B, so that there exists a contact force. This is F12. And here also there exists a contact force between 2 and 3. This is F23. This is the contact force. Throughout the journey, it moves with an acceleration A. Now what happened? Take the free body diagrams. Free body diagram means each block is separated from the system along with the forces and their directions. So first one, if I take the first block A, this is the block A having a mass M1, this is F in this direction, this is F12 is in this direction, this moves with an acceleration A. Therefore net force is capital F minus F12 is equal to M1A is the first equation. For the second one, if you take B, this is F12 is in, because F12 is in this direction, F23 is in this direction. Therefore F12 minus F23 is equals to M2A is the second equation. And third one is, see, this is F23. This is also having an acceleration, because all are in contact, they must have the same acceleration. And this is F, how much it is? 23, which is equals to M3A. So these are the three equations we got it. And now add equation 1, equation 2 and equation 3. So for block A, these are the two forces. For block B, F12, F23. And this is only this. Therefore, add all these three. Minus F12 plus F1, minus F23 plus F23 cancel. Therefore, F is equals to all the masses. M1 plus, M2 plus, M3 into A. Therefore, acceleration of system is given. A is equals to F by M1 plus, M2 plus, M3. Again, it is nothing but net force by total mass. This is applicable even for 10 or 20 or n blocks also. Suppose if n blocks of masses M1, M2, M3 up to Mn are connected, the acceleration directly given as the net force F by total mass M1 plus M2 plus M3 up to Mn. Like that we can directly calculate. Now contact force between B and C. If you take the contact force between B and C, it is F23. But from equation 2-3, it is nothing but M3A. Therefore, it can be written as M3F by M1 plus M2 plus M3 is the answer for this. That is the contact force. And again, if you want to find out the force, contact force between A and B, next one is contact force between A and B when you have taken. From equation 2 or from equation 1 you can easily calculate. From equation 2, what you will get? F12 minus F23 is equals to M2A. But F23 is nothing but M3A only. Therefore, F12 minus M3A is equals to M2A. Therefore, F12 is M2 plus M3 into A. Therefore, contact force between A and B is M2 plus M3 into F by M1 plus M2 plus M3. This is another. So, for any given numerical values of M1, M2, M3 and the force, we can easily calculate acceleration of the system of blocks. Is it clear? And then come to the other one, the tension force. These are two examples. The second part in this is tension in strings. Regarding this tension in strings, first of all, you must know that whenever a string is stretched with equal and opposite forces, then the reaction force developed in the string is called as tension in the string. That is, when two equal and opposite forces are applied at the free ends of a string, then the reaction force developed in the through the string is called tension in string. That is, when two equal and opposite forces are applied at the free ends of a string, then the reaction force produced or developed through the string or along the string is called as the tension in the string. That means, suppose if you consider this is a force F, this is the free end of the string, this is F, then the reaction force developed in the string, this is called as the tension. So, suppose if it is a string or a rope or a chain, whatever you take, whenever two equal and opposite forces are applied at the free ends, then the reaction force developed in the string is called as the tension in the string. So this is the first point we should have. And once you got the idea of this string, then the key points related to this. Then what are the key points related to the tension in the string? In that, the first one is the tension in the string is equal to one of the applied force. Suppose this and this are given, this is F, this is F, both are equal but opposite in direction. Now the tension is here is the Therefore, tension is always equal to one of the applied forces. The best example what you can say is, in a tug of war, the rope is pulled by each person with the same force. Let us say here the number of strokes applied is 400 Newton. Here also we are applying a force of 400 Newtons. If that is the case, what is the tension in the string? Since these two are opposite, if you can say it is zero, you are wrong, because the tension developed in the string is always equal to one of the applied forces. Therefore, the tension is always equals to 400 Newton. In a tug of war, the rope is pulled at the free ends with each with a force of 400 Newtons. Then, what is the tension in the string? If you are asked, it is always equals to 400 Newtons. This is the first point we should know. Next one. Second point. Point number 2. You may be given that when the system of when the string is inextensible. When the string is inextensible, that means there should not be any elongation in the wire. When the string is inextensible, then the system of blocks that are connected to the strings will have same acceleration. This is the second one. When the string is inextensible, then the system of blocks that are connected to the strings will have the same acceleration. For example, let us say this is a block A, block B, like that, having different masses. Suppose this is M1, this is M2, this is M3. If the string is inextensible, then all the blocks must have the same acceleration. So, when the string is inextensible, then the system of blocks that are connected to the strings will have the same acceleration. Next one. Third point. Point number 3. When the string is extensible, then the system of blocks that are connected to the strings will have different accelerations. That means, for example, if you consider this is a block, for example, this is an extensible string or like that. If it is applied a force, here this is M1, this is M2. Then what happens whenever it is given? Suppose this is like a spring like this one. The moment when you pull it, the string gets stretched. At that instant, the accelerations becomes A1 and A2. So, when they are connected and the string is extensible, for our convenience we are taking a spring, so that definitely you can observe the elongation. So, the string is extensible, then the system of blocks that are connected to the string will have different accelerations. And point number 4. That is, the fourth point is, when the string has mass or when the string is massless, then the tension in the string at every point is same. Then the tension in the string at every point is same. That means, suppose if you consider this is a suppose this is a block of mass m1, this is having a block of mass m2 like that. And then this moves down. The tension in the string at every point will be the same. When the string is massless, the tension in the string at every point is same. And another one, and the next point is here. Point number 5, when the string has mass, then the tension in the string is different at different points. When the string has mass, then the tension in the string is different at different points. For example, this is connected and a rope, this is what you are given. And now you are applying a force capital F. This is having a, if M has the mass of this one, at the point here the tension is maximum and here the tension is minimum. That means here the tension is maximum at the point where the force is applied and is minimum where the block is connected. So, when the string has mass, then the tension in the string at different points is different. At different points. It is maximum at the point where the force is applied and is minimum at the point where the force is, where the block is connected. And point number 6. That point number 6 is given by here when pulley is massless and frictionless. Massless and frictionless. When pulley is massless and frictionless, then the tension in the string on either sides of pulley is same. The tension in the string on either sides of pulley is same. Clear? When the pulley is massless and frictionless, the tension in the string on either sides of pulley is same. That means, suppose this is M1, this is M2 and this is massless, the tension on either sides of pulley will be the same. This is another point. And the last point here, when pulley has mass or friction, then the tension in the string on either sides of pulley is different. On either sides of pulley is different. When pulley has mass or having friction, then the tension in the string on either sides of pulley is different. Here, this is M1, this is M2, and here like this. This is T1 this side, then this side it might be T2 when pulley has a mass. These are certain important concepts related with the tension in the strings. This is also contact force only. So what type of conceptual questions that may come from this tension in strings will be discussed in the next class. Hope you understood well all these points. Tomorrow we will discuss concepts based on the tension in the strings. Thank you very much.